Hello Year 12 and welcome to the third and frankly last activity here for our third chapter. Right, we've been looking at graphing lines, and in particular now we are looking at not just one line but two lines, and not any two lines, certainly not a pair of parallel lines, because what do we know about parallel lines? They never meet, they never cross over, and we are specifically in this activity looking at lines that intersect, that meet somewhere, that cross over. Pair of straight lines that are not parallel on a flat surface will cross in exactly one place. Now, got a little scenario here. We've got these two rules. Rules, equations, same sort of thing. So, first rule says y is twice as big as x. Right? So that means that y equals two lots of x. Whatever x is, if I double it, that's what y has to be. So, not all pairs of numbers agree with that rule, but lots do. So, if x equals 1 and y equals 2, that agrees just fine because y is twice as big as 2. If x equals 3 and y equals 6, that pair of numbers agrees with that rule. Okay, because y is twice as big as x. Now if I said 2 and 5, that's a pair of numbers, but they don't agree with that rule. They don't follow that rule, right? So they don't apply in this case. They don't, in fact, satisfy that equation. Here's a fancy way of saying that. So that's my first rule. My first rule says that whatever x is, y has to be twice as much. I've got a different rule, right? My second rule that he says whatever x is, y has to be 3 more. Right? Y has to be 3 more than x. So once again, there are lots of pairs of numbers that satisfy or agree with this rule. Okay, 0 and 3. Right? X equals 0, y equals 3. Y is 3 more than x. 1 and 4, 2 and 5, and so on. Again, there are lots of pairs of numbers that satisfy that equation. What I'm looking for, though, is a pair of numbers that can satisfy both equations. A pair that satisfies the first one and a pair that satisfies the second equation. Now, for these two equations, y equals 2x and y equals x plus 3, we'll find that the numbers 3 and 6, right, x equals 3, y equals 6, that pair of numbers agrees with both equations. Because why? Because 6 is twice as big as 3, and 6 is also 3 more than 3. Okay, so that satisfies those. In fact, we could say that that is the solution to the pair of simultaneous equations. Now, how do we work that out? We can do it by drawing up a big table of values and maybe getting lucky. We can do it by using some pretty complex algebra, but we can also do it by drawing a nice, neat graph and graphing both of the equations on the same number plane, right, on the same graph. Right? If we do that, then the point where those two lines cross over or intersect, the coordinates of that point, the x and the y, will be the solution to both equations. So, let's give that a go. Here are these equations, y equals 2x and y equals x plus 3. We are going to graph these and verify that 3, 6 is a solution, and in fact is the only solution. Now, when we're drawing a graph, a table of values is probably a good idea. Let's say, ooh, that was a bit weird. What happened there? Okay, so y equals 2x. I have a table of values here, some x's and y's. Okay, x, y, pretty terrible x, and I'm going to have, let's say, negative 1, 0, 1, 2, 3, 4. Okay, so y is twice x, so I get negative 2, 0, 2, 4, 6, and 8. Right, that's one table of values. My other table of values needs to be y equals x plus 3. I'm going to use the same domain here. By that I mean the same sort of list of x values. Right, so for my x's and y's, I make up the x's, negative 1, 0, 1, 2, 3 and 4, and then I calculate the y's from that. So I have to take x and add 3 to it. So negative 1 plus 3 is 2, 0 plus 3 is 3, 1 plus 3 is 4, 5, 6, 7, etc. Now having a look at here, I want my graph, then my axes to go from, let's say, sideways from negative 1 to 4 at the very minimum, and from negative 2 up to 8. So let's draw this here. Right, that's going to be my x-axis, and I think we'll probably go, let's call that negative 1, this 0. Okay, so it's going to be my vertical axis through here. There we go, look at that. And this is going to be 1, 2, 3, 4. Probably could have made that a little bigger, couldn't I? But it doesn't matter. There's my x and my y's need to go. Call this negative 1, negative 2. Right down as far as negative 2, that's good. And we'll call this 1, 2, 3, 4, 5. We're going to run out of space, aren't we? 6. Stand well. Doesn't matter, we'll just improvise. 6. It's going to be 7 there. And 8 will be about there. Right, we can improvise a little bit. So, for my first one here, I need a negative 1 and negative 2. Negative 1, negative 2. Then 0, 0, which is called my origin. Then 1, 2. 2, 4. 3, 6. 4, 8. Right, I'm just going to do a little bit of this here. Okay, and you can see a nice linear function developing there. Oops. Now these do need to be drawn super neatly. Right, it's just that on a touch screen it's not super easy. Okay, so this is, we'll call this y equals 2x. That's my first one. Shouldn't do lots of lines like that, but also you should use a ruler. Next, y equals x plus 3. So negative 1 and 2. Okay, so I start here this time. Negative 1 and 2. 0 and 3. 1 and 4. 2 and 5. You can see I'm getting close here. 3 and 6. 4 and 7. Okay, now it is because these lines have a different gradient that they intersect. Okay, we said that parallel lines never intersect. Well, another way of describing parallel lines, saying they never cross, well, I think a bit more precisely, we might say that parallel lines go the same direction. Okay, and by going the same direction, they never get closer to each other or further apart. They always stay the same distance apart. Well, lines that are not parallel, lines that have different gradients, move towards each other at some point. And that point here is my solution. And across 3, up 6, right, there is my magic answer. Therefore, solution at 3, 6. Okay, I can see that the point 3, 6 is in both of my tables of values. Right, and it falls on both of those lines. That's the end of this video and of this chapter. Okay, I hope you enjoyed it. See you in class.